So the next question is demanding that we find theta. How do we find it? Let me check attendance and come. Hey, only 16 of us. Okay. I'll do the needful. Okay, so we have to find theta. Now, this material N1 has an index of refraction of 1.6, N2 has an index of refraction of 1.8. Please, which one is denser? Is it 1 or 2? Which one is denser? Is it 1 or 2?
2.
Oh, so 2 is denser.
Yeah.
Hello.
Please, are we solving the 29?
Yes. So we realize that 2 is denser than 1. So when light deviates or enters the second medium, will it deviate towards the normal or away from the normal?
Away from the normal.
Why will it be away? The light is moving from a less dense medium into a denser medium. Why will it be away?
It will move closer to the normal.
So towards the normal.
Or it will bend towards the normal.
Okay, so this is how it will look like. It will bend towards the normal. Okay, if we are to draw another normal here. So let's only talk about refraction here. Okay, from what we learned about refraction at boundaries, the product of the refractive index of the first one times and the sine of angle of incidence in it. So N1 times sine theta must be equal to, I want somebody to complete it for me.
N2 sine R.
So N2 sine R. Now listen to the question. Go back to the question. It said, in figure, light refracts from material 1 into a thin layer of material 2, crosses that layer, and then is incident at the critical angle on the interface between material 2 and 3. So this light crosses an incident on the interface between material 2 and 3. But the incident light, okay, incident on the critical angle. So this is C. Okay, now if this is C, because this angle and this angle alternate, this will also be C. So the angle of refraction in material 2 is also equal to the critical angle. Okay, let me draw it again. So light over here, let me increase the angle of incidence here. Yes, it will bend towards the normal. It will bend towards the normal. So if I draw another normal over here, okay, over here we are told the light incident at the critical angle of the interface between material 2 and 3. So it means that this angle of incidence in material 2 is the critical angle of this material. Okay, but since this angle and this angle alternate, If this is C, this will also be C. Please, are we okay? Are we okay?
Yes, please.
Now, if
Mr. Eja, please, I'm confused.
I'm coming. So if the light is incidenting on the critical angle of material 2, what will be the angle of refraction in material 3? What will be the angle of refraction in material 3? Yes.
90.
Class.
90 degrees.
90. So this must be 90. Total internal reflection. Whenever the angle of incidence is equal to the critical angle, whenever the angle of incidence is equal to the critical angle of the material, the angle of refraction is equal to 90. Okay. Now we are listening to the question. In the figure, light travels from material 1 into refracts from material 1 into a thin layer of material 2. Okay. Crosses that layer and then is incidented at the critical angle on the interface between material 2 and material 3. So it's incident on the interface at the critical angle between material 2, this is material 2, and material 3, meaning the angle of incidence, okay, within material 2 is the critical angle. So this angle, which serves as the angle of incidence from material 2 to 3, is the critical angle. If this is the critical angle, then this is also the critical angle because they alternate, isn't it? So if we are going by the refractive index of the
Mr.
first
Eja, please, I understand.
if we are going by
I
the
get it
refractive
now.
index of N1 times the sine of the angle of incidence, which is theta, it must be equal to the critical angle, the index of refraction of material 2 times the sine of the angle of incidence, refraction. But this angle of refraction is also equal to the critical angle. So this therefore becomes equation 1. Let me clean the board. So this is equation 1. Now, if we look at the deviation at the other boundary, we consider this one. Let's consider the other one. Okay. We can also deduce that the refractive index of 2 times sine of the angle of incidence over here, which is also C, must be equal to the refractive index of 3 times the sine of the angle of refraction over there, which is 90. Equation 2. Okay, we have N2. N2 is 1.8. So 1.8 times sine of C is equal to N3, 1.3 times sine 90 is 1. So from this, we can now find the critical angle. We can now find the critical angle. So sine C would be equal to 1.3 divided by 1.8. Find the critical angle for me. What would be the critical angle of the second medium? N2. What have you had for the critical angle?
46.05 degrees.
Is that what? CS.
46.05 degrees.
So 46 point, approximately 0.1 or approximately 46 degrees. I am approximating it. In exams, if you leave it in 2 dp, you are not wrong. Okay. Okay, so if the critical angle is this, help me find theta. We have two equations. Now we have found the critical angle here. Help me find theta. And I leave that to you. Today, where have you gone? I have only 19. Hmm.
Please, it's fine.
Okay. It must be fine. And what did you get for theta?
Mr. C or theta?
We are looking for the angle of incidence in medium 1. That is theta. We found C, 46, approximately 46. Time is over. Anita, what did you get? Yeah, what did you get? Okay, I do have seen yours. Yeah, Anita. Hey, they are not there. Okay. Eliana, what did you get? Hey, where are those? I'm calling.
Please,
Okay.
I got 54.3.
Yes, that's the answer. It's approximately 54.3. Let's see it. So we use equation 2, okay, to find C. Okay, equation 1 has theta within. So N1 is 1.6. So 1.6. Oh, this markers. 1.6 times sine of theta. And theta is what we are looking for. Is equal to N2 is 1.8. 1.8 times sine of the critical angle. And the critical angle is what we found, 46. So hooray! Sine theta, therefore, is equal to 1.8 times sine of 46 divided by 1.6. So calculator work. What is sine? Multiply sine 46 by 1.8. Then divide by 1.6. What will that give you? Sine 46 times 1.
0.81.
Come again.
0.81.
1.81.
0.81.
0.81 over 1.6. Okay, so theta, Gloria, when you divide
Miss
0.81,
Cynthia,
yes,
please, I did the whole thing, like 1.8 times sine 46 over 1 over 6, and I got 0.81.
okay, all right. So it means that theta will be the sine inverse of 0.81, and that should give you the 54.3 degrees, approximately 54 degrees. So that's the value of theta. So simple. Gloria and are you okay?
Yes.
Okay, now look at the follow-up question. The second question which follows. Please, let's read it. The B. If theta is decreased, is there refraction of light into material 3? And Priscilla, once you joined last time, you couldn't complete this thing with us. It will give you problem, but I'll fix. Just be around. I'll fix a day so that those of you who are not clear will go through it again. Okay. So listen to the follow-up question. If theta is decreased, is there refraction of light into material 3? If we decrease theta, if we decrease this, would there be refraction of light in material 3? Think through it and answer. Please look at it carefully. If theta is decreased, would there be refraction of light in material 3? As at now, the light is in material 3 is on the boundary because this is the critical angle. Okay, C. Now, if theta is decreased, would there be refraction of light in material 3? If you are ready to answer, please alert me by raising your hand to call you. If you've seen the trick and you want to answer, else you answer by force. Let me go and call somebody. Adubia is here. Adua, Anita, I call you, don't respond. Deborah is here. Liana is here. Ella, Gloria, Mary, Marvel. Okay, then let me call Adelaide. Adelaide, what do you think? Adelaide, if theta is decreased, would there be refracted ray in the medium 3? Adelaide, or Adelaide is going to open the lid. Okay, Ella. Ella, what do you also think? Hey, no one is talking. Oh. Okay, marvelous. Let me hear from you. If theta is decreased, would there be refracted ray in medium 3? Hey, Hello.
Lydia, please. If theta is decreased, theta is decreased. It's no sorry for my
If we decrease
Instead,
theta,
I think there'll be no refraction.
why?
I don't think there'll be refraction in the third medium because the critical angle will decrease as well.
And
Okay,
so
Mr. Lydia, please. So it will reduce the amount of lights that will be incidented in the second medium than the third medium. I'm not very sure.
that is Marvelous's view. Okay, let me pick Ajua. Ajua, what is your opinion? What's your opinion of this? If theta is decreased.
Is the idea, please? It's same as Marvelous, but I'm thinking of why there will be no refraction.
If there will be no refracted ray in medium 3. Okay, Mary.
Yes.
Mary, if theta is decreased, what do you think will happen? Mary is going to marry. Okay, then let me take it up myself. If theta is decreased, Marvelous, Ajua, and Co, there will be refracted ray in medium 3. Why? This is the why. As Marvelous, as you said, when you decrease theta, the critical angle would also decrease, as you said. Now, when do we form total internal reflection? If an angle of incidence in the denser medium is increased progressively, okay, as the angle of incidence in the denser medium is increased progressively, a certain angle of incidence would give us an angle of refraction of 90. And this angle of incidence in the denser medium, which gives us an angle of refraction of 90, is known as the what? How do we call this special angle of incidence? Yes. It's known as a critical angle. So how do we obtain the critical angle? If you don't know, you increase the angle of incidence in the denser medium gradually. So when you increase it to a certain extent, then you have an angle of refraction of 90. Okay. Then the total internal reflection will come in when we go beyond, when we increase the angle of incidence beyond the critical angle. Now this is a decreasing situation. So once the critical angle is being decreased, okay, we wouldn't have an angle of refraction of 90 because here we are not increasing the angle, we are decreasing it. We are decreasing the angle of incidence in medium 2. And once you are decreasing it, that angle we can't achieve an angle of incidence which will even give us this angle of 90 in 3. So it's like once you are decreasing, then this will shift away. It will shift away from the boundary. And then there will be refracted ray within medium 3 instead. Please, are we okay?
Please,
No.
can you
You see, Marvelous, you just said that if we decrease the angle of theta, the critical angle also decreases. I hope you are all okay with that. If we decrease this, C would also decrease. Are we okay?
Yes, yes, please.
Now, if C would decrease, we earlier said that we obtain critical angle when the angle of incidence in the denser medium is gradually increased. a certain angle of incidence in the denser medium would give us an angle of refraction of 90. And this angle of incidence in the denser medium, which gives us an angle of refraction of 90, is the critical angle. So first, we obtain the critical angle as a result of progressively increasing the angle of incidence. Okay, and when you get to the critical angle of the material, the angle of refraction in the less dense medium is 90. Are we okay here? Are we okay with this?
Yes, please.
Yes, please.
Now, after obtaining the critical angle, you are now decreasing theta. You are now decreasing it. What it means is that the refracted ray, which is now on the boundary, will shift away from the boundary, and then will rather come within the third medium. So as you decrease it, because C is also decreased, this will continue to shift away. So as you decrease theta, you have refracted ray in the denser medium. That's what I'm saying. Are we okay? Hello, are we fine?
Mr. Edia.
Hello. Are you okay?
Not really.
Marvelous, here you are not okay.
Mr. Ede, I understand the fact that when we decrease the angle of when we decrease theta, the critical angle also decrease. But I don't understand the parts where there is a refraction in material too.
It's unfortunate.
Mr. Ede, because if
my 1 minute would even elapse soon.